Hello everyone. Today we are discussing about Automata theory project about computer science domain area questions. We are group of three, myself Saipritam Kannati and Aditya and Likit Mitapalli. Aditya, can you scroll? Thank you. The domain is computer science domain area questions. Here we have three files. The first one is the grammar file, and the second one is the documentation file, and the third one is the Python file. And domain we selected computer science based questions. That is our domain. Based on the domain, we have selected some statements and we have constructed them like CKY tables, and for each valid and invalid sentences. Firstly, we have some grammar name CFG. It's called context-free grammar. All the statements are called productions. How we can call is in here we can see like S implies NP and VP, NP VP, and this whole line is called the production, and the and S implies AUX NP, and it is another production. The left side one is the arrow. We have only one term, S and P and nominal, but in the right side, any number of terms like 2, 3, or 4, that is called context-free grammar. And I'll check and go down. Yeah. And the noun like data structures, textbooks, and reinforcement learning, we can call them as the nouns. All these terms we are added because they are required to the statements to text valid or invalid. These are the sentences we consider for computer domain. These are the sentences for the computer domain. Like I considered 25 sentences because we are group, so that we took 25 sentences. In this we considered two as invalid and 3 invalid statements. CFG converted into CNF. CNF is called as Konski normal forms. The difference between the CFG and CNF is, in CNF we have the production, and in the CNF production the right side is only allows 2 non-terminals. Here S implies NP VP, and here S implies ADVP and ADVP and VP, like that, everything. That's it. From here, Aditya will continue. Thank you.
Hi everyone, myself Aditya. So I'm explaining about the CKY tables. So how we obtain this one. So here we are telling like whether the statement is valid or invalid based on this last box. What we have got the result. If we got yes on the last box, that means the statement is valid. So if the last box is not getting in a S, means that means it's an invalid statement. We can consider that as an invalid statement. For suppose we can take an example of this statement called what methods in data structures. So initially what, so in what, in the grammar file we find what as auxiliary. Here is a what, and it's an auxiliary. So we kept what as an auxiliary. And methods, so methods we call it as a verb here. So we can find methods in the verb. And in is a preposition. So in the grammar file we find in as a preposition. So and the data structures and we consider it as a noun. Here we consider it as a noun. So first we need to complete this diagonal, and after completing this diagonal, and we need to move to the another diagonal up down here, and after the moving this this diagonal, we need to go to the next diagonal. So in this way we need to complete the process. So that's so now we need to consider the relationship between what and method. So we need to consider this row and this column. So methods. So method should be an auxiliary and VP. Auxiliary and VP, and so we don't find any auxiliary and VP combinations here. So that's why the box is empty. So and now we need to find the relationship between in and this what. So that's why we need to consider methods and in. So we need to consider this verb column and this in verb row and in column. So verb and preposition. So we need to find verb and preposition in this combination. So we have verb and NP, but we don't find any verb and preposition. So that's why this box is also empty. So now if we need to consider the relationship between the in and data structures. So we need to consider this row, this preposition row, and this data structures column. So we need to go with the combination like preposition and noun. So preposition and noun. So here we find it, preposition and noun. So we call it as a PP. So the PP comes here. So now we finish with this diagonal. So now we are moving to the next diagonal, this one. So now we need to consider the relationship between the what methods in. So we need to consider the methods, this methods row and this in column. So we don't have any values here. This box is empty. So that's why we got this box as an empty. So for the data structure, so we are considering the whole sentence. So we need to consider this verb row and this end column. So preposition and verb. And so the preposition and NP. So PP. So only the PP we have. So the value PP we consider it as a VP. So the VP we kept in this box. And now we are considering the relationship between this. Only we left with this box. So we need to consider this in box and this NP and VP box. So we need to find the relationship. So NP and VP. So here we consider it as an S. So we written S here. So as we said earlier, like if this box have got yes in the last box, so then the statement we can consider it as a valid statement. So in this the similar way we have done the CSCI table for all the 25 statements. So these are all of the 25 statements. And one in we considered 3 invalid statements as well. So if we see the invalid statements, the boxes, the last box, it doesn't get any value like S or anything. So that's why these are considered as an invalid statements. These 3 are invalid statements, and based on this we prepared a code under the Python language. So from here my mate Likit will explain.
Likit, I think so you was in the mute. Can you?
Oh, sorry. Yeah, I'm Nikit. In this project, we have done code using Python language. In this, we use the module called WordNet Lemmatizer. This is used to perform lemmatization on words. And mainly, this project is like based on computer science area questions. So where we give sentences from computer science course. For whichever statements we pass as input, we get output as yes or no based on valid or invalid sentence. For this, we have created some set of CFG rules and we have made them into a file called grammar file. And we need to import this file into the code. So when we run the code, it records the file and depending on the rules, it gives the output as yes or no. So here, whatever we pass as input, we get the output as yes or no. And coming to the code, I will share this. Aditya, can you give me access to screen sharing?
Yeah, just a second. Yeah, you can go ahead and share the screen.
Okay. This is the code for this project. And here we need to import the file from the file. Once we execute the code, it is showing successful executor. And we need to give the sentence here as we done in the file. Yeah, it is successfully executed and the statement is executed with S so that it is an valid statement. And I will try for another sentence. And this is also executed successfully and it is we give an output as yes. And I will give one more sentence which is valid statement.
Data structure spelling maybe see written wrong like it.
Yeah, and give output as yes for valid statement. And coming to the invalid sentences, yeah, here it shows as no because the statement is invalid based on the rules from the grammar file. It will read the context and coming to the one more invalid sentence. It will also show as no because this is an invalid statement. And mainly we have used the flag statement. If flag is true, it prints yes, and if flag is false, it prints no as an output. And that's all. Thank you. Mm.
Yeah, thank you, Likit.
So this is our project. So we took the 25 statements for this project to check whether the valid or invalid statements. So, and we consider it as a computer science domain. So this is our project. That's it. Thank you.